So thanks for responding to my poll. By far trigonometry won out that you wanted a video on. So I've chosen a question 2018, paper 2, question 8. It kind of gives a good overview, lots of little bits of trigonometry that you could be asked. So what you need to remember in trigonometry is for right angle triangles, you're going to be dealing with Pythagoras and SOHCAHTOA. And for non-right angle triangles, you're going to be using the cosine rule or the sine rule. So if you open up question 8 in 2018 paper 2, you should have it in your exam papers. If you've already done it, you can get a new copy of it on StudyClicks or Pocket Papers or something like that, so that you can maybe try it along with the video. My advice would be to pause here, try the question, and then check your answers watching the video. So part A asks us to use the Theorem of Pythagoras to find RQ. So we have to look on our diagram, where is RQ? So RQ is this line here that we identify there. And remember, the Theorem of Pythagoras is that c squared equals a squared plus b squared. So we need to label our lines A, B and C. So obviously we're going to label the hypotenuse as C and then A and B. So 6.5 squared equals what I'm trying to find out, RQ squared plus 3.3 squared. So RQ squared equals 6.5 squared minus 3.3 squared. Or RQ then is equal to the square root. We'll get rid of that squared of 6.5 squared minus 3.3 squared. You can put all that into your calculator and you'll find out that RQ equals 5.6 meters. So that should be relatively straightforward. If you have any problems with that, make sure you go back to your maths tables, find the Pythagoras theorem or in your textbook. So part B asks us there to show that alpha is equal to 31 degrees, correct to the nearest degree. And if you look at your diagram, you can see there that alpha is that angle that's part of the triangle RQP. So how do we show that that's 31 degrees? Well, it's a right angle triangle, so we're going to be talking about SOHCAHTOA. And in this case, I have the hypotenuse and I have the opposite side to my angle because it's right across from it there. It's the opposite. So I'm going to use sine. So sine of alpha equals the opposite, 3.3, over the hypotenuse, 6.5. Now remember, if I want to find the inverse of sine, I use the shift button on the calculator and I get sine, and we write the inverse as to the power minus 1. 3.3 over 6.5. If you put that into the calculator, you get approximately 31 degrees. Now in the next part of the question, in part C there, you're asked to find beta, which is this angle here, beta. And you can see that alpha and beta together make a straight angle, which would be 180 degrees. So the easiest way to find that angle would be to take 31 away from 180 and you get 149 degrees. There are a couple of other ways to do it. You could find the two sides and add them together there, or there's a few other ways around it. But I think the easiest one is to see that as a straight angle, take away alpha. So in part D, we're asked to use the cosine rule, which gives us a hint there that this is a non-right-angled triangle. And we are asked to find the length of RS. So RS is the long side of the triangle where we have found beta in it. So beta is 149 degrees. And I know that RQ, one of the sides, is 5.6. And I've been given that another side is 8. So I'm looking for that long side there, how I need to calculate it. So go to your formula and maths tables, write down the cosine rule, and then we're going to label the sides. So I've written there my cosine rule. A squared equals b squared plus c squared minus 2bc cos a. I always make the angle that I know the a. And the side opposite to that then is going to be small a, and the other two sides then are b and c. So I'm going to substitute those in and we're going to calculate it then. So I've substituted in for a, b and c and for the angle a, and that's what I get. I don't want this squared on this side, so I'm going to take the square root of the whole lot and that will get rid of that. So you can put the whole lot into your calculator, and it said to give your answer correct to the nearest meter, so to the nearest whole number. So it will be 13 meters. So that side RS is 13. Makes sense, it looks like it's the longest side. In part E, you're asked to find the length of the arc, which is the curved part there from S to T. So sectors are similar to triangles, as in we can measure the angles, but remember that they're like a slice of a circle. It's like a slice of pizza. You're finding a fraction of the circle. So the whole circumference of a circle, if you looked in the maths tables, you'd find the formula is 2 pi r. And we're finding a fraction of that. So you'll see the formula is theta over 360 by 2 pi r. And r is the radius and theta is the angle. So if I have a look at the sector, well, I know A over here is 31 degrees. So the opposite angle to that is going to be 31. It's making a right angle or straight angle, sorry, with that one, which is 149. So we know it is definitely 31 degrees. I can see what the radius is from the center of the circle out to the circumference is 8. And it's that on both sides because they're both from the center out to the arc. So r is equal to 8. So if I put 31 over 360 multiplied by 2 by pi, you can use your calculator to do pi, or 3.142, and 8 meters. And if I put that into the calculator, I get 4.3 meters when I do it correct to one decimal place. In part F, you have to find the area of the sector. And the area of a sector then is very similar formula, because you're finding a fraction of the full circle multiplied by how you would find the area of a full circle, which is pi r squared. Again, theta is your angle and r is the radius. So we're going to have 31 over 360 multiplied by pi 8 squared. And if you put that into your calculator and it wanted to correct to one decimal place, you get 17.3 meters. Now, if you have any questions about any part of this video, just let me know on Teams. My advice would be to pause just before the questions and then go back and check, did you get it correct?